Hello dear children, hope you're all fine and keeping safe at home. Children, in the last module, we elaborately understood the working of our hearing organ, ear. Hope you watched the video. In this module, we are going to discuss some of the characteristics of a sound wave. That is about amplitude, time period and frequency. Children, let us revise a concept. When a wave passes through a medium, particles of the medium get displaced temporarily from their original undisturbed positions. Children, what happens when sound travels through air? We saw in the last video, isn't it? The air particles or the air molecules move back and forth. They transfer the energy and they come back to the original position. The same happens when water is disturbed. The water particles are displaced from their original position and that is visualized as a wave. Let us take the case of a simple pendulum. Children, we have studied about simple pendulum in our previous videos, also in your earlier classes. When we take the bob from the mean position A to one of the extreme position B and release it, what happens? The bob or the pendulum continues its motion by going to C and again through A it comes to B and it continues its motion. And we know that this back and forth or to and fro motion is known as a oscillation or a vibration. So when we just try to plot it in the form of a wave, see children, we can see here the blue line, it shows the undisturbed position, that is the mean position of the bob. But when the wave motion starts, that means from the point A it reaches to the extreme position B, again it comes to the point A, again it is displaced towards the other side and it reaches the other extreme position C and again come to the mean position A. So this is a wave, a sound wave, or this is a vibration that is represented. So this height of the wave is known as the amplitude of the sound wave. So when we say about amplitude, it is actually the displacement of a particle from its mean position. Amplitude, noted by the letter capital A. So let us define amplitude. The maximum displacement of the particles from their mean position is called the amplitude of the wave. The SI unit of amplitude is meter. Amplitude determines the loudness or softness of sound. That means if the particles are displaced more from their mean position, the sound will be loud, and if the particles are displaced less from their mean position, the sound will be soft. Amplitude depends on the force with which an object is made to vibrate. That means if more force is exerted on an object, the amplitude of vibration will be more, and vice versa. Loudness. From the previous slide, we understood that the loudness or softness of a sound is determined basically by its amplitude. So soft sounds have small amplitude, whereas loud sounds have high amplitudes. Loudness is proportional to the square of the amplitude of vibration producing the sound. Loudness is expressed in a unit called decibels. Above 80 decibel, the noise becomes painful. Children, how can we represent a quiet sound and a louder sound? Here it is. So the sound which has less amplitude is a quiet sound, as you can see, and a sound wave with higher amplitude is a louder sound. So now let us watch a video which will help us to understand how does the amplitude of vibration depends on the loudness of sound.
Pour some water in a metal glass. Now strike the glass with a spoon and observe the sound. First softly, then a little harder, and again very hard. You observe that the loudest sound is produced when the glass is struck the hardest. Now we will test the amplitude of the sound waves. keep the glass near a thermocol ball which is hanging from a string. Let the ball slightly touch the glass. Now again strike the glass and observe the ball. We see that the thermocol ball gets displaced more when the glass is struck harder. This shows that the glass vibrates with more amplitude when it is struck harder. So we can conclude that difference in loudness of sound is due to difference in the amplitude of waves it produces.
Children, let us understand the second property, time period, noted by the letter capital T. You are familiar with this property since you have studied in last class. The time taken by the wave for one complete oscillation is called time period, or the time taken to produce one oscillation is called as the time period. The SI unit of time period is seconds. Time period is calculated using the equation time divided by number of oscillations. Children, you can see here three waves or three vibrations, and you can see the time taken to produce those vibrations. And if you want to calculate the time period, how can we do it? Okay, time period is equal to, what is the total time? 12 seconds. Divided by how many oscillations? 3. So, what is the time taken for one oscillation? Yeah, it is 12 by 3, that is 4 seconds per oscillation. It took 4 seconds for producing one oscillation. Hope you understood. Children, what is frequency now? Frequency is a property of a sound wave. It is defined as the number of complete oscillations produced by an object per second. Its SI unit is Hertz. If one oscillation is produced in 1 second, we say the frequency is 1 Hertz. Frequency is calculated using the equation number of oscillation divided by time. Frequency multiplied by time is equal to 1, or we can form two equations, that is frequency is 1 by time period or time period is 1 by frequency. Children, we define frequency. We have to now understand a term that depends on frequency. We can distinguish between a man's voice and a woman's voice of the same loudness even without seeing them, isn't it? This is because a man's voice and a woman's voice differ in pitch. So children, what is pitch? Pitch refers to the frequency of sound, or it is a characteristic of sound by which we can distinguish between two different sounds of the same loudness. So we can say the pitch of a sound, it depends on the frequency of vibration. The higher the frequency, the higher is the pitch. The lower the frequency, the lower is the pitch. Usually a low pitch sound is described as a flat sound, whereas a high pitch sound is described as a shrill sound. Okay children, so we'll understand more about loudness and pitch, and we'll conclude today's portion in the coming video.
Close your eyes and listen attentively to what you hear. You may hear someone whispering, walking, or talking. You may hear sounds coming from outside the classroom, like the chirping of birds. Sound is produced when the strings on a rhubarb vibrate. Sound is produced when our vocal cords vibrate. You can feel this yourself if you hold your hand against your throat and say, ah. In short, sound is caused by vibrations which travel in the form of waves and reach our ears. Sounds can be soft, such as the rustling of the wind, or they can be deafening, such as the boom from a plane. We enjoy some sounds. They are pleasant like music. Some sounds are undesirable, such as the sound of traffic on a road. We can identify sounds according to how they differ. Sounds can differ in pitch and loudness. Let's look at both terms one by one. The pitch of a sound tells us how shrill or deep it is. Like hello and
Hello.
observe that the girl's voice is shrill and the boy's voice is deep. Let's take a closer look. The pitch of a sound depends upon the vibrations of sound in 1 second. That is, the frequency measured in hertz. The greater the frequency, the higher the pitch, and the lower the frequency, the lower the pitch. Since male voices tend to be deeper than female voices, male voices have a lower pitch, or in other words, lower frequency. Let us consider 2 more examples: blowing of a whistle and call of a hoopoo bird. Which of these 2 actions will produce a higher pitch? In the case of blowing of a whistle, a greater number of waves pass in 1 second. It means that it has high frequency, which results in a high-pitched sound. In the case of a hoopoo bird, however, fewer number of waves pass in 1 second, resulting in a low-pitched sound. Next, let's discuss the loudness of sound. The loudness of sound basically tells us how loud or soft a sound is. When we talk to our friends, our voice is soft, but when we address a public gathering, our voice is loud. The loudness of a sound depends upon the amplitude of the vibrating object. The larger the amplitude, the louder the sound. It is measured in decibels. Consider this example. If we strike a drum lightly, we hear a soft sound. It is because the sound produced is of low amplitude. However, if we strike the drum harder, we hear a louder sound. In this case, the sound waves have a larger amplitude. Hence, the amplitude of sound waves determines the loudness of sound. The pitch of sound depends upon its frequency, while the loudness of sound depends upon its amplitude.
Children, here are some points which are given that you have to write down in your notebook. So hope you will write it neatly in the front side of your notebook and revise the topic. Thank you.